So section 10.3, inference for regression and correlation. So in the last section, we computed the sample linear correlation coefficient. So how do we know if there's enough evidence in the sample data to conclude that a linear relationship exists in the entire population? So to answer that, we always perform a hypothesis test. And in this case, the parameter we will be testing is rho, which in the last section we learned is the symbol for the population linear correlation coefficient. Okay, so for this next exam now we've got two new symbols. We've got lowercase r, which is the sample linear correlation coefficient, and we have this new one, the Greek letter rho, which is our population linear correlation coefficient. All right, so we're going to look at the same process that we have before for hypothesis testing. So we're still going to be following the steps of phantoms. So our first step was we're going to state the parameter along with the random variable that we're going to use for its estimate. So in this case, rho is going to be the linear correlation between whatever our two variables are for all of the objects that we're looking at, where a random variable r is going to be that same thing for just the n randomly selected objects that we have. Again, for the hypothesis, again, we could have either a two-tailed, but typically we're going to be looking at the left-tailed and right-tailed tests. So again, either we're going to be testing, so for a left-tailed, we're going to have rho less than 0, and this is going to test for a negative linear relation, or we're going to have rho is greater than 0, and this will test for a positive linear relation. Again, there's a really long list of assumptions that would need to be checked for linear regression, but in this level of class, we're just going to look at two of them. So the set of XY ordered pairs in our sample from the population of all such possible XY pairs, and we need to make sure that the scatter plot of X versus Y is roughly linear with no outliers. Step 4, we're going to name the hypothesis test that we're going to use, and in this section we're going to be using the linear regression t-test. Then we're going to find our sample statistic and then kind of the standardized form of it called the test statistic. So in this case, our hypothesis test is about rho, our population linear correlation coefficient. So the one from the sample is the value of r. And so r, that value is going to be on the output screen. Again, earlier in the section we had the formula for how r is computed, but we are never, ever, ever going to use that formula. So we're just going to grab that from the output screen, whether that's StatCrunch or your calculator. But then the standardized form of that, so our test statistic, we're going to take that value of r, and we're going to divide that by the square root of 1 minus r squared over n minus 2. So again, this is a t-statistic that is still going to be measuring how many standard deviations away from the claim our observed value of r falls. Okay. Our next step in phantoms is to obtain the p-value and to make a graph that makes sense out of all of these numbers. Again, we're going to largely be focusing on left-tailed and right-tailed tests in this class. So again, on that bottom on our horizontal axis here, if we go up to step 5 with the test statistic, we're going to have r as a random variable, and then the standardized form of that, the random variable is t. So our axis is going to get labeled with r and t. Again, under the claim, the claim is that rho is equal to 0 and the null hypothesis above, so we would expect an r value near 0, and t is always centered at 0, so all of these graphs have zeros at their center. And then again, we have the same logic that we've had in all the other sections with hypothesis testing. So when we go to make a decision, we're going to compare the p-value to alpha. If the p-value is less than or equal to alpha, we reject, otherwise we will fail to. And then finally, the last thing is to state the conclusion in the context of the problem. So if we reject HO, then there is significant evidence to conclude, and we would write what HA says in context. Or if we fail to, then there's not. And again, keep in mind, we never say except HO. Because in a hypothesis test, we start by assuming HO is true to begin with, unless there's significant evidence to the contrary. Okay, so a hypothesis test can never prove that HO is true, because we start with that assumption in the beginning.